All right, I'm super happy to be here in Helsinki. This is my first time. I've been, as Lucas was mentioning, collaborating with Lucas over for the last, 5 or 6 years now on the Cloud Native Nordics, and it's my first time to be in Helsinki and in Finland in general. So I'm super ecstatic to be here. Today I'll talk about OpenTelemetry and Perses. So if you're here for the Finnish version of without the S, that's not going to happen. I just learned that yesterday, but it's not that. It's an observability tool. So just briefly about me, I work as a developer advocate at a fairly new startup called -0 in the observability space. I was co-chairing KubeCon. Spent some time before KubeCon trying to reach the Golden Kubestronaut title as well. I know there's at least one in here, other Golden Kubestronaut. I'm not sure if there's other here, but it's a really fun challenge to try and get the 13 CNCF certifications, and then they threw in like a Linux Foundation system administrator at the end as well, which was a little bit annoying, but it was fun. So basically, I live and breathe communities. I think this is awesome infrastructure, all the intersections between what we're doing, what we're working with on a daily basis, and then meeting and sharing experiences. And yeah, I just think that is awesome. So today we are talking about OpenTelemetry. How many in here are actually using OpenTelemetry? Oh, that's a good amount of people. Also in production, that's a fewer people. That's good. What about Perses? None. I sort of expected that as well. It's a fairly new project in the CNCF. It's a sandbox project, but we'll come back to that later. So the TLDR is really that OpenTelemetry is standardizing telemetry collection. Perses is standardizing dashboarding. And if we're applying like platform engineering principles, we can transform observability into a seamless, scalable, and developer-friendly experience. And building on open standards allows you to freely move between different vendors because now the collection part is taken care of. That allows you to move between the different vendors more easily. And we'll come back to that in a second. So let's get started. So for many years, observability was like fragmented. We had metrics, we had logs, we had traces, and in practice, all of these were like separate pillars that were sort of spun out of some need, and different tools collected metrics, different other tools collected logs, and a third tool for traces, and 3 different query languages, so the 3 browser tabs of observability as well, right? And in practice, we don't have a metrics problem or a tracing problem, we have a systems problem. And yet many of us still have like 3 different systems running. We are relying on humans to correlate between these different tabs in our browsers, which is error prone, and it's really not how modern observability should work. Instead, sorry, that's a little bit later. But this fragmentation, it leads to many different challenges. We have complex query languages. Again, 1 query language per signal you have. We have vendor login. If you were early on in your tracing or distributed tracing journey, you probably have like a proprietary agent that are collecting and doing all kinds of different things. It's really hard to get out of that. We have metadata inconsistency between these different signals and tools. It's really hard to take one thing from one tool and correlate that into another tool. And due to this high complexity, many are actually skipping instrumenting, not doing tracing, basically not doing getting the insights they potentially could. So that leads to lack of unified insights, and it makes troubleshooting harder, more error-prone and inefficient, and it's really forcing you as engineers to piece together information across these different systems, and that's not really how it should work. So that's really where there's a shift happening now in this space. It's a shift toward correlation, that we are now trying to correlate all of these different signals, because, so we are moving from these isolated signals into correlated insights. So instead of treating like telemetry as scattered data points, we are starting to connect them to see, like in this case where you're jumping from like a metric, you can dive deep into a trace, and then from the trace into a specific log that sort of gives you maybe the root cause. And that allows you to reconstruct the chain of events more easily. And that's really what the tools that are building on top of this is trying to give you out of the box. So that you are in 3 a.m. in the morning when all problems occur, apparently, it should be hopefully more easy for you to figure out what's going on more quickly and solve the incident. This is just an example from our product in terms of correlating the different signals. So you have a trace, you can jump from the trace to the logs, and you can also go up and see the aggregated metrics. So having that insights and making it easy for you to jump between the different signals is really what is important. And what is really driving this is OpenTelemetry. It's more than it's not just about collection. It's really a movement toward better observability. One agent to rule them all, consistent APIs and conventions, and really a community that is building sort of the foundation of how modern observability should work. And if we have a closer look at this, OpenTelemetry is an open source project designed to provide standardized tools. It's sort of become the de facto standard for distributed tracing. There was a lot of merger between open sensors and open tracing, and that is what is OpenTelemetry today. It supports metrics and logs as well. And the main goals are really to have unified telemetry, vendor neutrality, and cross-platform. That's sort of the main goals. It allows you to instrument in various different languages, like all the common languages, like Java, Go, Python, whatever language you can probably come up with. There should be like an instrumentation for that, an SDK. And in fact, OpenTelemetry is the second largest project within the CNCF by contributor count. And last year had more PRs plus issues than Kubernetes itself. It's right up there, as you can see. There's a really big momentum behind this project. And what this shift is really about standardizing how we are collecting data. So it's all about like generating and emitting, transmitting, collecting, converting, processing, routing, exporting, and then send that to some storage solution somewhere. And as you can see in this picture, there's a lot of different things within OpenTelemetry as a project. It's an API, it's an SDK, there's some auto-instrumentation. It has this OpenTelemetry collector, which is what you use to receive your telemetry from the different signals. You can do all kinds of processing in there, and then you can export it to wherever you like. And then on the sort of the other end is all the vendor space. So now we are moving sort of all the collection, all of that is standardized now. Now the vendors are sort of battling on like the storage solutions and the analysis tools and what really makes you efficient. I think that is really, really powerful because you can just, in your exporter, your collector, you can basically export to 3 different vendors and you can test out which vendor is sort of best for your solution or for your problems. So in a nutshell, it's all of these things. It's a data model, it's an API specification, it has semantic conventions, we'll come back to those in a second. It's libraries implemented in all the languages. It's a lot of utilities, and it's all kinds of different things. There's more than 80 repositories within the OpenTelemetry project as it is today. And it's not proprietary. It's not like an all-in-one solution for you, so don't expect that. It's not a data storage. It doesn't have dashboarding. It's all about collecting and standardizing that part of the pipeline. Yeah, and it's of course still under heavy development, but and close to be a graduated project. There's a PR on the TOC right now, so hopefully that will be resolved soon when the TOC gets time to actually like validate, and then it will hopefully become a graduated project very soon. So telemetry without context is just data, and if an OpenTelemetry without context or without semantic conventions is also just data. So what I want to say about this is that semantic conventions is part of the project as well. It's really a way where we're defining like semantic attributes that we all agree on that this is what we call like an HTTP status code, or a client span looks like this, or all kinds of different things. All things around Kubernetes is standardized how we are collecting those signals. And there's semantic conventions for all of these different things, and you can find them on the OpenTelemetry semantic conventions repo. Just an example here. This is from the official OpenTelemetry.io docs. It's just about like client.address, client.port. All of this is standardized. It's just for you to know like uppercasing, or we do it like this and we do it like this. This is all standardized as a specification we all follow. That makes it a lot easier to build on top of. And what also is part of this project is something called resource attributes. And resource attributes is really how we are representing the resources that we are sending the telemetry from. So that could be a container in Kubernetes. It has a process name, it has a container name, it has a pod name, it's running in a namespace. There's all kinds of this information that is really interesting about this resource, and that is what we put in our resource attributes. And the cool thing is that you don't have to do anything in this case. If you don't want to, you can do all kinds of things manually, but it has this concept of resource detectors, where it basically, if you run in Kubernetes, it will detect that. If you run on AWS, there's an AWS ECS detector in this case. That's a good GCP detector. So it will sort of detect all the different metadata around your resource and add that as a resource attribute. So that when you are in need, you can drill down fairly easy to figure out what is this. Is it a node? Where is it running? Which container was it? Which namespace is it running in? All of this. And you can, of course, also add this by yourself if you want to. I don't recommend that, but you can do it. And you can also do a lot of things within the processing step of the OpenTelemetry collector as well, which is quite nice. So this is just an example from Kubernetes. Namespace, .name, pod name. This is all part of the resources, and the other side is more to show you sort of the log attributes. So if you're logging, you will probably have log IO, stream, file path, or whatever. So it's all about, where the data is coming from, and makes it easy for you to investigate and drill down when you need it. So why OpenTelemetry? So you now can instrument once, and you can use this everywhere. As I mentioned before, you can basically define your collection step, and then you can send it to the different backends that you want to use. We are in this. We are also separating like telemetry generation from the analysis step, as I showed you in the previous graph, which is again really powerful because now we are fighting. The vendors are fighting in a different part of the entire pipeline. And then a lot of open source projects are now coming with OpenTelemetry and instrumentation out of the box, meaning that if you are using, I don't know, a Java framework or something, it will automatically produce a lot of metrics for you, or telemetry for you, which is quite nice. And being able to correlate basically improves out how we use telemetry, and it makes it easier for you to, jump between the different signals. And I'll show you that in a demo in a second. But it doesn't have to be that, that's fine. That's all great, but how do I make it easily accessible for my developers? So when you really think about it, OpenTelemetry isn't just a tool, it's more like a platform for how we are collecting data. And I like to sort of correlate it to platform engineering as well. I've used these as like the principles for platform engineering in the past. And I think they sort of correlate very nicely with OpenTelemetry as well, because you have, in the self-service experience, you have auto-instrumentation, you can auto-instrument, you don't have to do anything as a developer, you can actually inject everything automatically, and I'll show you that in the demo. We have the semantic conventions, which is explicit and consistent APIs, it's a specification we follow. Golden path, we built this into everything, so you can build this into whatever platform you're running, auto-instrument your applications. Modularity in terms of collector pipelines, you can basically do all things in the collector pipeline as you like to. And a lot of other things, because I can see my time is running pretty fast. But it's really about the same thing. It's a platform that makes it easy for our developers or your developers to get a lot of instrumentation out of the box. So if you focus a little bit on the self-service part, the project also has this operator that comes with these 4 CRDs. And the one I want to show you, focus most on today, is the instrumentation. It's really about auto-instrumenting whatever language you are using and getting that telemetry out of the box without touching the code. And I'll show you that. It also have support for like target allocator, which is about scaling Prometheus, collection, and stuff like that. But that's for another day. So auto-instrumentation, it looks something like this. You provide like an instrumentation resource, tell it, I want to inject this in, this is the language is Go, so inject this into my application. And in the operator, it's supported for these 5 languages as it is today. I'm sure more will come. It's just about the community getting behind it and adding more instrumentation out of the box. But collection of telemetry is only part of the story, right? We also need to make sense of it. And that is really where Perses comes in. Perses is a CNCF Sandbox project, and it's really about standardizing how we do dashboarding. It's an open specification for dashboarding. So it looks something like this, and I will also show you in a second. It has these goals of providing this specification. It's about making it integratable into all different kinds, all different projects. So there's an NPM package if you want to, I don't know, inject it into Backstage or something like that. It's GitOps friendly, so you can also write this in YAML, so you can add it to your services repositories and have dashboards locally to your applications. And yeah, a lot of cool things. You can also, if you don't want to write it in YAML, they also support Go and Q. So there's also other ways than YAML to write your dashboards in code. And it, of course, also has an operator. All tools have an operator, right? And it comes with these resources, and I'll show you them in a second. Because now I want to go to the demo. This is what you will see in the demo. It's a local kind cluster that I have running on my machine. I have two applications, a to-do application written in Go and one written in Java. They use like different databases, and then I have the operator. I will add the instrumentation resource that I told you about before, and we'll auto-inject instrumentation into these two applications and show you that you don't have to touch the code and get a lot of telemetry out of the box. We'll use a collector and send it to Prometheus as a backend for metrics and Jaeger as a backend for the traces. Logs we are skipping for now. So let's try and see if everything works. And hopefully this is big enough for everyone to read. So this is the cluster, and this is all the stuff that I have running in it right now. I have, down here, we have the operator, which manages like a few collectors. I'll show you those in a second. This is the Perses operator, which manages Perses, which we have up here. We have the to-do applications, and then we have some databases, as I showed you. So this is sort of the layout. If you just take a quick look at the OpenTelemetry collectors, as you can see, it's like it's a CRD in the cluster. I have two of them running right now. One deployed as a daemon set because I have node-level telemetry, like I want to pick up logs from the from the different nodes. I want to have like interaction with the kubelet to get metrics from the kubelet out. You can get all kinds of different information there. And one deployed more as a central tool which talks to the Kubernetes API server, gets some cluster-wide metrics and stuff like that instead. So that is sort of the recommended best practice to deploy these two, one as a daemon set and one as a deployment or stateful set, as you please. So if we just quickly take a look at let me just see, OTel collector, to see some YAML. I guess everybody loves YAML. So this is the resource. We have it right here. As you can see, it's an OpenTelemetry collector. We are picking up logs from the different machines. We do a lot of things, but the most important thing is really about services we have down here. If you haven't seen like a collector specification before, this is really how you're defining how to collect the different signals. So let's go down to metrics. We have a receiver, which is OTLP, which is the OpenTelemetry protocol. We are receiving data from that. We're also getting like information from the kubelet stats, which is another receiver that gets information from the kubelet itself. Then we can do a lot of different processing, and we can export it to wherever. In this case, I'm exporting it to Prometheus, and I'm also exporting it to Dash0. But it's just to show you that you can really combine the exporters and export it to wherever you want. You can also like to export it to like an S3 bucket or do some cold storage if you need that. In the processing step, you could also do redaction of some stuff that you don't want to have go into your pipelines or whatever it is. There's a lot of options there. And it's more or less the same for traces. Cool. Let's have a quick look at the application. So we'll kick off with the Java application. It's a Spring Boot application. As you can see, this is just the sort of the application entry. Nothing in here about instrumentation or anything like that. We'll take the controller. Oh, wow. Controller. No, sorry. It's not Java. There it is. Again, what you should really note down about this is that you don't see like any like imports around telemetry, metrics, anything like that. It's just plain Spring Boot of how you're defining a REST controller in this case. So you have like endpoints that you would expect in this. So in order to instrument this without touching the code and get a lot of telemetry out of this application, we have this instrumentation resource that I was talking about before. It looks like this. It defines, of course, namespace, but then you specify where you want the data to be sent to. In this case, I want to send it to the collector that I showed you just before. We have different options for how we want to do sampling. If we have like always on, so we get all samples, or you can sample in any way you like. You can do specific for the different languages. You can do a lot of different things. I've done some specifics for Go to get it to work. There's still some issues with the OpenTelemetry Go auto-instrumentation. It's a little bit weird in the sense that it uses eBPF, whereas the other are more like bytecode direct instrumentation using an agent. So let's just quickly apply this. Instrumentations. Perfect. And what we see is that nothing really happened. Nothing. You need to opt in this case. So you need to add this. Let me just grab the annotation I need to add, which is this one. There we go. So what we'll do is we'll edit the deployment to do Java, and we'll go down to, let me see. It's a little bit hard when I don't have a mirror here. Spec, containers, labels, there we go. So we'll add an annotation. Insert this, and as this was Java, so we will inject Java. So this is really the only thing you need to do is really add this annotation, and then you point to the resource that I just showed you before, the instrumentation resource. Oh. Yeah, that's probably it. Thank you. Yes. There we go. Perfect. Thank you so much. So now we see stuff happening. We'll just wait a second. Error, of course. Yeah, it's failing. There we go. Let me just grab this one and show you what happened. So if we describe this pod, you will see that it now added a few things in here. So a few OTel specific environment variables was added, but the most interesting thing is really the Java tool options, which is that it adds this Java agent, the auto instrumentation agent, to this application. During startup, it will run this, and that is coming from, where do we have there we have it. It's coming from this init container that is managed by the operator itself, so it will inject this, and then it will get auto-instrumented out of the box, which is quite nice. I can see I'm running fairly low on time, so I should probably speed up a little bit. Oh, what happened? Let's just open a new window. There we go. Okay, so stuff is weird. Okay, so what I want to do is I want to port forward. I want to send some requests to this just to show you that this is actually working. Just open a new window again. Do some curl. So I just want to like interact with this application. So I'm just curling. So I buy some hotel T-shirts or buy something. I don't know, Finland something. Not buy Finland. That's weird. Let's just stick to the hotel. I don't want to be Trump in this. So if we move to Jaeger, which is like our tracing tool, you will see that nothing is working because I just killed my port forward. Just a second. There we go. Hopefully this works. There we go. So if you find traces, you will see that now we actually have traces from the application itself, and we can take this, and you can see that, yeah, it does a post, it does calls, all kinds of different things, and then interact with the database. So this is the client span of how we interact with the database in this case, and all of this was came out of the box without touching any of the code. which is quite powerful. And you can do the same for all the different the other languages as well. I don't have time to show it in Go, but the only thing about Go is that it adds as eBPF sidecar, which comes with like security trade-offs as it is right now, because you need to run that as root as it is. I know the community is working on making this a lot better, so hopefully that will be better in the future. But just note that if you want to try it in. So quickly to the Perses. And now I'm not in the right repo, sorry. Cube. There we go. So Perses. So for Perses, we have this data source. So we need to define a place where the data is coming from, or where we can query the data. So in this case, we just want to have it query the data that was in the local Prometheus installation that I talked about earlier. This is how we do that. So we'll apply that. Perses. Prometheus. There we go. And then we have, of course, a dashboard. We also want to see some metrics, and in this case, we'll just use a JVM metrics dashboard. And we go to the top. There's a lot of YAML here. Sorry about that. There we go. So what you have, you define different panels, time series charts, how you want to lay this out. You define your Prometheus queries. This is really the format. This is generated, so don't look at all the UIDs and stuff like that. It's generated in the tool itself. But basically, you lay out your dashboard and all the queries, and then you can define how it should be laid out using a grid down here. So it's fairly easy. Just apply this fairly quickly. Perses JVM, and then hopefully this works. So this is how Perses look like. It's sort of the server. And we have a JVM metrics dashboard, and we have some metrics here from the application as well. So that is really how it works. What we are doing at Azure is we're using Perses as sort of the way you define our dashboards. We are building on this open specification. We are hoping other vendors will join us in this as well. I know a few is working on this as well. So it's really great if the community as a whole could come together and allow you to define your dashboards, so you can take them from one vendor and move them to another, and use the OpenTelemetry collector to ship your data wherever you want it to be, because that gives you a lot of freedom. So back to my slides, and there we go. So it's really powerful that you're able to use like an operator to auto-instrument this out of the box. Of course, in some cases, you might not want to do this, depending on your organization. But it's a really good starting point to like get some information out of the applications that are running. And now, especially with all the community coming together and auto-instrumenting all of the libraries and frameworks are being auto-instrumented out of the box, which is super, super nice. So you get actually quite a lot of information out of the box. So observability is evolving really, really fast. I can see I only have 1 minute left, 2 minutes left. So there's a lot of things going on in this space. And I think really that OpenTelemetry is standardizing the collection part. That is more or less how it is right now. So the days of fragmented data are numbered. My head of product is saying that OpenTelemetry agent will be the last agent that you will ever install. Hopefully that will be true, because then you don't have to have all of the proprietary vendor agents running. And it also frees the vendors to build like specific instrumentations for all the different languages, so they can, again, fight in another place that would benefit you as an end user. And again, Perses is hopefully standardizing dashboards in the future. I really hope that this will be how we are defining our dashboards in the future. And by applying platform engineering principles, we can transform observability from this afterthought into a seamless, scalable, and developer-friendly experience. Again, this observability is a systems problem. It's not a metrics, logging, or tracing problem. We have a system that's really where the issues are happening. And when we connect signals together, we empower developers to solve problems faster. And building on open standards allow you to freely move between vendors, ensuring that they stay on their toes and provide you the best possible experience. And just a shameless plug, it's open source, so I think it's okay. If you're playing with the OpenTelemetry collector, we created something called OTel bin. it's really a way for you to visualize how your different pipelines is looking. It's really awesome, and you can actually validate your configurations against different distributions of the collector. It's a really powerful tool. And with that, I think I'm 10 seconds from Lucas screaming at me, so thank you so much for attending.